Alright guys, today I'm going to show you how I make starship coils. This is what a starship coil looks like. This is the first one I ever made on a little jig. It looks like it's been bent and all sorts of stuff, because it has. It's actually been melted and all sorts of fun stuff. You can see that one right there is kind of melted. These are all shorted together. I actually did a Lenz's law demonstration and this just smoked. But it's okay. That was the purpose. So, that's a starship coil, and I'm going to show you how to make one. I got a couple other coils here I want to show you real quick. Starship coil. This is embedded in glue. There's actually, if I were to put a guessing game out there, let's just do that. How many sticks of hot glue gun, let's rephrase that, how many inches or feet, either one, did I put into this coil? Okay, those are the dimensions. Here's my hand. Alright, how much hot glue is in here? You guys figure that out. Alright, so I got that starship, this starship, and this starship, the only ones I've ever made. Here's a regular Rodin coil. You've all seen this. And a starship coil exactly hits those same points. So it's the same as a Rodin coil, but pancaked, and you only wrap it on top of each other. It saves so much time and it puts out a great amount of magnetic power. Alright, let me get it set up here. Okay guys, right here I have a piece of wood. On this piece of wood I have glued the starship coil winding jig on here. What it is it's a circle with every 30 degrees marked out. Now I have 2 holes on here for each point because I did some special windings, but basically you hit every 30 degrees all the way around here, so you hit 12 points. And then you wrap the pattern in this star-shaped pattern. HHO for volts, this is actually his diagram he made up. I just glued it on here. Printed out, glued it on here. That's what size of coil I got. Let's see how this fits on here. Now I'm going to show you a trick, at least that I know that I have found out a better way or an easier way to do this, as far as winding goes. As earlier I showed you guys how I wrapped this wire. Okay, I found out if you have the wire overhead, so I'm working down here, you just have the spool floating up here in the air somewhere, hang it on something. That makes it easier. Okay, so most people, or some HHO for volts originally started using golf tees. Works pretty good. I still use golf tees. Some people use nails and all sorts of stuff, but right now it's just golf tees. So I got my jig, I got my holes drilled out so my golf tees fit right in there. They're real snug. Okay, so that's the winding jig. Now here's what I have found out makes it a whole lot easier. Get yourself another piece of wood or a jig or whatever you want to do. Get yourself a real thin washer and a screw or a nail. Okay, I already got a hole in here. Put that washer on there. Drill a hole in the center of your jig, right in the middle. Place that washer in between the 2 pieces of wood. Okay, screw this down. Here's what you got. You got yourself a bearing, if you will. Okay, so now when I wind, I can turn my jig. Makes it a lot easier when you're winding the starship coil, because you just wrap. It goes by real quick. Alright, so let's set this up. I always have an extra pin or 2. That's where I wrap the wires that are coming out of the coil, and then go through my coil and then wrap it back out here until I get this secured. So I'm just wrapping 1 wrap. I'll go ahead and put on my pegs in here. You might want to test these. I did wrap a starship coil and 1 broke. I was halfway through. I went ahead and finished it, but it could have been better if it didn't break. Alright, I'm going to get my jig set up here a little better. Camera changed. Okay, I got my timer set up here because I'm going to fast forward this footage so that you can see how long it takes. Okay guys, I got my spool dangling from the ceiling here. Okay, so it's just floating. Just keep it out of my way. That's all it is. And I like it to be overhead a little bit. It seems to work better. Alright, so I got my wire up here. I'm going to get the end of my wire. I'm going to take I don't know, about a foot or so. And I'm just going to wrap it around this start pin. All this does is keep it out of my way. Now you want to kind of make this wadded up or whatever so that you can spin the jig. Alright, here we go. Start my clock and I'm just going to start winding. Easiest thing to do, I'll go ahead and start it, but I'm going to talk anyway. Easiest thing to do is keep it towards the bottom. So I always just put my finger here and just hold it towards the bottom. That didn't work out, did it? Okay, and I just hold it towards the bottom the whole time. Like so. I try to pull tension on it, but if you pull too much, you start pulling your pegs over. But just follow the winding pattern. You can get it wrong quite easily, to be honest, even though you wouldn't think you'd be able to, so just pay attention to what you're doing. Okay, now I made it to the first wrap. And what I'll do is I get a pencil out, piece of paper, I'll make a mark. One. Okay, here we go. Crap. That's what I'm talking about, guys. No worries. Hold it out. Put another one in. That's what I get for putting too much tension on these things. Pulling pretty tight. I lighten up. Alright, continuing. Okay guys, so I've got, let's see, 5, 10, 15, 20, 25, 30, 34 wraps on here right now. And you can see how thick it is. You can look at the inside and you see how clean it looks. It looks all nice and flat and square and it looks all neat. Unfortunately, it's hard to keep it like that, as you saw in my coil where I hot glued it. It looked really nice. It stayed. It held its form. Unfortunately, this, when you start to get to the top, gets a little tricky. You just got to kind of keep pushing the corners down, and I've got a lot of pressure on these, so that's why that one broke. But you just keep on going. I'm gonna go until I run out of wire here. Got a couple wraps left, so here we go. Okay guys, check this out. This is rather interesting. I'm getting close to being out of wire, and my Starship coil is actually above my picks there. You can see it actually starts to grow out, which is rather interesting because I'm pulling it out further on the heads. It's not real good, but that's okay. I'm just going to keep going. I'm almost out of wire. Alright. I really can't fit any more wire on here. The first part of this video actually, my camera got messed up, so the time kind of jumps, but that's okay. Alright, here's what I got left on my spool. Only a couple wraps, not really very many. Actually, the amount of wire that I had on here was a lot more than I thought. I bet it was closer to about 400 to 500 foot, maybe even more than that, because my other coil had, this coil has, let's see, 260 plus 260, so 400 and like 500 and something foot. I bet there's 600 to 700 foot on this Starship coil. That's a lot. But check it out. It's pretty interesting. something interesting kind of happened. It started growing over top of the pegs, and the Starship coil winding started flaring out, which is rather interesting. Kind of gives me an idea. But now what you want to do is get yourself some zip ties. I'm going to go ahead and cut this wire off. I hate wasting recycled wire, but I'm going to have to do it this time. Alright, I got some little zip ties here. And what you want to do is pull one peg out at a time and zip tie it on there. I actually like starting here and then going there and back and forth and back and forth. So I'm just going to pull one out. And there's a lot of pressure on these things, like a lot. I just stick it in there like this. Zip tie it down, that's it. Pretty simple. Okay. That is a fat Starship coil. Jeez. Look at this one here. This is the first one I ever wrapped. Granted, it's been smashed a lot. Check out the difference. It's huge. Here's my other coil. I told you there's probably a lot more wire in here than I thought, but it is thinner wire than this. So there's probably, I'm still gonna guess about 400 foot. There's quite a bit of wire here. But that is essentially how you build a Starship coil. I want to thank Richard, or HHO for volts. I want to thank you for sharing this cool coil. It's interesting, to say the least. It's got some interesting properties to it. And snip these off. I kind of straighten the ends out a little bit. I like to try to keep it nice, keep its look. And there is a pretty cool Starship coil. Ooh, I see you through my Starship. That don't make sense. Sorry, guys. Alright, I guess I'll leave you with that. Now you know how to build Starship coils. I'll show you this coil again. It's rather interesting. Hold it real close so you can see it. It's actually twisted Liz wire, and this is copper and aluminum. This wire is probably around a number 26. Might be like a 24, somewhere in there. This one's I think it's the same actually, 26. Looks a little bit bigger. It's probably a 24. This is probably 26. But that's how you wrap a Starship coil. And I hope you all enjoyed that. And yes, I did happen to pull these really tight and break one off. That's fine. It happens. Alright, enjoy. I hope to get those other Rodin coils finished, but I had some time I wanted to show everybody how to make one of these because it's very interesting. HHO for volts did a good job showing that, and I just wanted to show you a possible improvement over the jig with this. It helped out a lot. Alright, this is Russ. I'm out. Have a good one. Hey guys, little tech specs on this coil. One I just built. I wrapped it with 63 turns, so 63 12-point turns. It's got 756 point-to-point wires, and I calculated those to be out around, this is a very rough estimate, 327.7 foot, but I would give or take 50 foot, probably more on that. It measures 21.3 ohms, and that's it. Alright, keep it real.
Hey everyone, I'm putting this video out just kind of to show how simple this thing really is. You know, here I've got a coil, a very small little circuit board here with basically 4 devices, 2 diodes, a resistor, and a transistor, a switch, and this light bulb which indicates that it's actually running, but this one barely glows, so we probably won't be able to see it. I mean, you know, and then two batteries. This one is going to run the show, and we're going to charge this one. There's no wires connected to anything else but that. I just have the meters. You know, it's just that. Very simple. So turn the thing on. And that bulb is just barely glowing. I don't know if I turn my lights off here or not, if we can see it. There it is. Tiny little glow, but can't see it. Anyway, so here you are. You can see that battery's getting charged up. You know, here's the one running the show. So this tiny little battery is charging this bigger battery with nothing but this coil and the small circuitry. How beautiful is that? That's all I can say. So I just wanted to demonstrate the simplicity. You know, you can see this is holding its own pretty well for now. I mean, you know, this thing can only run for so long, but see that voltage going up. This thing's set on a pretty conservative setting right now. If I lowered this resistor, it would actually charge a little bit faster.
Hi, this is Jack. This is a blotch wall resonator that I made, and it has a vertical mount for the shaft, and it is a magnetic mount so that it's floating. You can see there the disc magnets are mounted opposed so that it floats in there. So the bearings are only needed for the lateral support, and then the drive coil is here on the top, and this is the 7-point coil. And it produces about 400 volts or more of back EMF. You can see here on the scope. It's running about 5,000 RPM, and it has back spikes of at least 400 volts. It goes off scale even at the times 10. So I'd say probably 500-600 volts. And you can see here the neon. There's a neon here on the voltage. It also has some secondary coils. The main drive coil here is this thing in series, the star coil, 7-point star coil. And then I'm experimenting with the blotch wall effects and also the Faraday homopolar generator, where there is some voltage produced from the shaft over to the edge of the rotating disc magnet. So one of the disc magnets is rotating and one of them isn't. But it's interesting. You can have this thing runs pretty quiet, and it runs on a vertical shaft, so there's no load on the bottom. It just sort of bounces around in there. And of course I'll be trying it out with a lot of different coils to see what kind of effects I can get. I haven't made an update for a while, so I wanted to show everybody what I've been working on. So thanks a lot, and this is Jack, and signing off. See you later. Bye.
Check this out. This Ocean's is out here in my mad science laboratory. 7 plus 5 is 12, 8 plus 4 is 12, 9 plus 3 is 12, 10 plus 2 is 12. 11 plus 1 is 12, and you end up on 12 on the other side and 6 down here. So you might look into some of the old sacred geometry stuff. It's pretty interesting stuff, that things that can be calculated within a 360-degree circle. The clock is pretty fascinating. You can calculate things up all different directions. But either way, I made this nifty little coil to run a few tests. This is a one-wire system. This wire right here, which runs down to that coil right there, has a little stainless steel probe on it. So the rest of it, none of it's grounded. What I'm going to do, before I get that far, let me show you over here. I put an LED right here on my earth battery, and so when there's high voltage running through the dirt, that LED will light up. So let me fire this up for a second and see if you can see that. I don't know if you can even see that. Let me kill light here for a second. Alright. Also watch the numbers as that LED comes on that voltmeter. Notice they'll start to rise pretty substantially, and that LED comes on. So with that said, what I'm going to do is take the probe from the one wire off the coil there. I'm going to set it up here on the wood next to these spectrum tubes. I'm going to fire that up. And so, we'll bring us back down over here. Maybe too close. Let's try that right there. See if you can see both LEDs. No. Should be able to see two of them. Alright, there's one there. You'll notice that when I put my hand on there, they get brighter. Then my probe, there, right up here, here's my probe. Alright, now I'm going to take my probe all the way around over here. I'm going to connect it to my ground. And so you know that's the ground, I got my hand on it. Alright, so now I'll bring you right back around here to the coil. And you notice that the lights are substantially brighter. I'm still connected to the earth ground, the dirt. This is why I need virtual labs, because I need to be able to show real time from all directions what's going on at any given time, because this specific anomaly with these particular coils is pretty intriguing to me. Now, it's a one-wire system right here. This one wire running this coil right here. That's the one I've got connected to the earth ground right now. But you can see that when I touch those coils, how much more bright those LEDs get. Now, I'm going to keep my hand on the coil. There. back on the ground. I'm going to keep my hand on the coil, and I'm going to bring the probe around the front. You can see that they're still lit up. Alright, put it back on the ground. So, whatever it is about the Rodin coil, it makes a really, really good receiver. Okay, I'm going to bring it back up by the plasma again. Notice that's right directly with the plasma. Not near as bright as connected to the ground. And if you look over here, that LED, which is right there, is lit up. And the numbers on my dirt battery, my earth battery, are going nuts. Alright, so back on the ground again. I'll try to set this in there and get it to stay. Alright, there we go. I've got to make an adjustment over here. I can tune this whole system from this one spark gap right here. It's actually 4 spark gaps on the side. But you'll notice that whenever I tune this down, that will dim out. And the plasma will dim out. Here. Alrighty then. So, see over there on the monitors, quite a bit of disruption. That's without. Bring it back down here. Alright. Well, it's getting late on in the night, but I thought I would share that with you. That's one of them really cool anomalies. If you go over and look at Abrams Labs video, you'll see that they got some magnetic coupling going on, some coupling between the field, and he doesn't even actually have to touch the bulb, which I've been showing you guys for quite some time. It's pretty cool stuff. But I believe this coil's worth looking into a little further. Let me know what you think. If you like this video, give me a thumbs up. It's like almost 1:19 a.m. in the morning here my time. It's about time for me to get some sleep. I keep losing my doggone ground over here. Alright everybody, this is completely disconnected now. It's just picking it up out of the air here. There's my deal. Yeah. I'm bushed. Good night everybody. Peace and love. Stay tuned. Take care.
This is for Russ. I don't know if this has any sound to it or not, but hey, check this out, man. Here I got this, battery charger. As you can see in there, there's the Starship coil wrapping. I just got some stainless steel screws coming up. I don't know if you can see those or not in there. Hopefully you can. I'm going to turn this on over here to about, I'm going to turn it to the 6-volt position, fast charge, and there you go, man. That's the HHO production off those little screws right there. I don't know if you can see that or not. Try to get a good shot in there. Looks like we're getting some really massive HHO production off just 6 volts, man. That's that Starship coil, and I don't even have the screws. I don't even have the screws all where I said I'd put them, because the plate that I used to get this all together started cracking on me and stuff. So here we go. We'll turn that off. There it is. No production, and back 6 volts, and here's 12 or 6 volt 2 amp, or no, it's 12 volts 2 amp 6 volt engine start. So that's 12 volts 2 amps it's supplying right there, and there's 6, back down to 6. I don't really see much difference in the 6 and the 12 in the production. Alright, man. So well, I guess we'll see what happens. I'm gonna try to build a bigger model, change it out, and see if we get better results. This is just something I slapped together real quick.
I'm here representing the vortex-based mathematics project, which was founded by my teacher, Marco Rodin. Almost 40 years ago, Marco discovered an unknown mathematical language inherent to nature. I'm here speaking because I'm at the forefront right now of the most advanced mathematics ever known to mankind. The saying is that mathematics is the language of God, but until now, no one's been speaking God's language. What we have is the grand unified field theory. With it, you can create inexhaustible free energy, end all diseases, produce unlimited food, travel anywhere in the universe, build the ultimate supercomputer, artificial intelligence, and obsolete all existing technology. How is it possible to make such outrageous claims? Because we have the secret that connects all of the world's technologies together, numbers. We discovered that numbers are real, a living language, a jigsaw puzzle that when pieced together no longer creates a rendition or approximation of reality. Numbers are reality, neither flat, nor arbitrary, nor imaginary, nor irrational. They are actually points or locations that fold out into a 3D shape defining space and time literally. Mr. Rodin discovered an equation that was so eloquent in its simplicity that it involved no more than 9 numbers around a circle. And with it, you can do all the functions of all the branches of math instantly. It displays a perfect spin symmetry of numbers forming mirror images just like our 2 hands, a feat that's baffled countless scientists and mathematicians. When you look at this symbol, you immediately see it's composed of 2 aspects. One is this lazy 8, or the infinity symbol, and the other is the red pyramid at the top. The infinity symbol is the equation for the physical world we live in. It's a circuit or a pathway of motion. 6 numbers that form a hexagon. Thus, such diverse phenomena as light polarizing, beehives, Saturn's North Pole, and snowflakes are all versions of this hexagon. These shapes form pathways for any matter in motion, which is never straight, but always at an angle. Nothing in the physical world ever moves in a straight line, not a bullet shooting, not lightning coming down out of the sky. This pyramid is representative of what we call flux fields. We have electricity. At the center of electricity is magnetism. At the center of magnetism is a flux. It's a higher dimensional energy known by many names such as dark energy, tachyons, monopoles, gravitons. We call it etheron energy. It's the energy that's keeping us conscious and alive, and it's not a static or stationary energy. It's a pulse, it's a surge, it's the beating heart of all existence. It's the ultimate fundamental particle in the universe, the God particle, and I know how to harness it. This energy is the source of all time, motion, and vibration. It's the only thing that comes from the whole, or the zero, the center of the cyclone. It emanates linearly in all directions, penetrating everything without any resistance. It cannot be shielded. As it penetrates, it leaves a grain. It shows you how things move, how they stick together or come apart. It animates everything. It's the source of the non-decaying spin of the electron. If you combine it with a coil, you get a perfect mathematical vortex. Ultimately, when this is arrayed in true 3D shape, which is what I discovered, it forms a shape commonly known as a torus or a donut. This is nearly 20 years later. What I found was this. Essentially, this thing is a heat sink. It's a temperature regulator, just like your human body. The universal geometry designed for maximum efficiency and energy transformation, and an ecological method by which the universe reprocesses matter, using it as a coolant source. Torus is what everything becomes at its maximum acceleration. This experiment you're going to watch while I finish my talk, I want you to keep in mind when you're watching this magnet spinning around, there's no energy going into this coil. It's totally turned off. And I'll continue. Your blood cells are a torus. DNA is a torus. Magnetic fields, galaxies, all toruses. That's why a tornado is more powerful than an atom bomb. It's a one-way, living, systemic electrical machine. A self-sustaining jet, you might say a flying saucer. I found the way to calculate this torus in a perfect 3D, 4D, and higher mathematical hologram that can be scaled up and down to infinity, and which we now call the Abha torus. Or sometimes we refer to it by Marco's name, which is the flux thruster, atom pulsar, electrical venturi, space-time implosion field generator coil. And with it, it's possible to create a localized space-time implosion, a controlled desktop black hole. That magnet's still spinning. There's no energy in the coil. This is the final technology, the philosopher's stone, a reactionless drive unaffected by any weight that it carries. It's a true model of an atom, and with it I have the key to the periodic table, which a professor from the University of North Carolina told me could be the greatest scientific discovery of all time. we can, for the first time, cross from one science to another, unbroken, whether it's subatomic physics, periodic table, computer science, DNA. Remember, I said cure all diseases, artificial intelligence, all the result of ether-on flux fields. And so simply put, this torus does it all. It's a blueprint for a perfectly efficient magnetic field generating coil, a spaceship, a surgical tool, a supercomputer, and even a high-fidelity speaker all in one. Are such things possible? Frankly, yes, they are, and my team is ready to develop them at any time. What you see here was just from the most primitive approximation of my work. But the truth and reality of our project is it suffered from a tremendous lack of attention. We want to turn it into the hands of the people to produce and save the whole world. Thank you very much. This information is not to be privatized or exclusively owned by any corporation or individual. Instead, it is our desire to create an open source project to freely share information with the public. This device is a version of what we call the ABHA torus, developed by Daniel and Erica Nunez.
Hello everyone, this is Daniel Nunez with OneStopEnergies.com. Today I'm going to show you a free energy work in the progress. So let's check this out. We're using vortex coils today, and let's look up on the roof. That's an old antenna, and that old antenna is not being used because nobody uses that type of television antenna anymore. So what we're doing here is we're running that wire down from the antenna over down this way into our PoE Mini. And what's happening here is that we're collecting the energy from the antenna with this little simple circuit for rectifying radio wave signals. So what we're doing is we're collecting electricity over here. So as I change the frequency, I'll be able to generate more power, because right now I'm actually using less power. So resistance is all the way down. The coil is not resonating right now. So I'm able to charge up my little capacitors over here. So you're looking at the DC voltage, that's 1.9 volts. And that's charging up those two little capacitors there. And these are buffering capacitors, so those regulate the frequencies. The little black diodes, they force energy in one direction, so it creates a mandatory charge into those two capacitors. Now I have a different circuit. This is the same SEC circuit we've been running for pretty much majority of our experiments. I've got a 1 mega ohm potentiometer on there, and a 3.4 volt LED. So you can see we're already charged up to 2 volts. And let's go ahead and spike this energy. This is all free energy, and let's give it the right frequency. And I'm just turning that little knob. There you go. So you saw the flash. That discharged my capacitors, and now they're charging back up again. And let's look for that frequency again. There it goes. Discharge my capacitors. Let's do it again. So I'm lowering the frequency and then raising it back up. So give it a little charging time there. There it goes. That's a spike of free energy.
But essentially, this is defining a pathway for matter in motion, the path of least resistance. And numerically, that's defined by doubling. Okay, so that's one aspect of what this equation is. It's defining a doubling sequence. Now, then we have this 396. Well, what's the 396? Well, if you look into studying physics, you know, there's really only two things you can study, right? If you look up the definition of physics, it's defined as the study of matter in motion. Of course, then what is putting matter in motion? What is causing the matter to move? What is the source of time, motion, and vibration? And that's where you get to the number 9. Okay? But before I go to the number 9, I want to talk about 3 and 6. Well, what are 3 and 6? Okay? 3 and 6 represent the absolute extremes. They end in the middle of nowhere, and as an engineer friend of ours says, nothing mechanical does that. Okay? Everything mechanical connects to something else. Nothing mechanical ends in the middle of nowhere. The 3 and the 6 do that. Interestingly, 3 doubled, if you double 3, following the same process, is 6. 6 doubled is 12, 2 and 1 is 3. 12 doubled is 24, which equals 6. 24 doubled is 48, which equals 3, right? They oscillate back and forth. Now, the only thing that we know that oscillates is magnetism. And that is really essentially what this is defining. The other aspect of physics, other than matter and motion, are what we call fields.
Testing observations. Controllable low voltage ozone production, multiple magnetic monopole detection, energy gains using a 1-to-1 ratio, 1-to-1 ratio coils, coil sensitivity to the Earth's magnetic field, bioelectric interactions with the coil, energy reduction when charging batteries or spinning magnets, synchronization of multiple rotors at different axes, plasma excitation through the center of a vortex coil, increased growth rates in plants around coils, self-cooling properties when running high voltage, very large magnetic fields for little input power, 576 LEDs illuminated using only 1 watt of power, and many more. And today I'm going to show you how to make your own PoE vortex coil design. For step 1, we're going to set up 2 hooks 50 feet away from each other. Step 2, securely tie your wire around the hook. Step 3, now walk the wire back and forth 24 times. Step 5. Snip the wire from the spool and tie it around the bundle. tightly. Step 6. Get your wireless drill and connect your hook to it. Step 7. Now it's time to twist. Step 8. Now that we use the drill to twist the wire, it's time to spool it. Find a comfortable spot because now it's time to wind the coil. We will begin by doing the counterclockwise wind first. Up and over. When it met the starting point, you're just going to skip one above it. Step 10. When you meet the starting point, now you may begin the clockwise wind. Just note that after the very first loop, you will be going directly under the starting point. Step 11. Now that the winding is complete, it is time to take the torch and melt off the enamel at the end of the wire. We are melting off the enamel, so when it's time to solder, it's easier to make the connections. Step 12. Now it's time to sand the ends and remove the burnt enamel. Now for step 13, you will need an alligator clip and your multimeter. Take your alligator clip and connect it to any of the wires. Right now, we have 48 wires. So being that it made the connection, this is the finish, when this is the start. Take the finished wire and connect it to any other wire. And you're going to repeat this process 11 times. So now that I finished with channel A, this makes it one wire, and I'm going to proceed to doing the same thing I did with these 11 connections on channel B. That sounds is channel B completed. Now for step 14, we're going to solder all the connections. For step 15, get electrical tape and put it around the ends of the wire that was soldered to avoid the connections touching. Now that you have successfully finished wiring and connecting your PoE vortex coil, it is time for testing. We're going to take channel A and connect it to the amplifier, and channel B and connect it to the amplifier. Now for the last two wires that are remaining, they are going to be connected to the 192 LED panel. Turn it on, and voila. Thank you very much for your time. This is Erica Nunez with OneStopEnergies.com. Please share and spread the word. Many blessings.